So good morning. Today we'll see about the prioritizing of hands-off. One scheme for prioritizing hands-off call request is called the guard channel concept, in which the part of the existing channels in a cell is reserved entirely for the handoff call request. The major drawback of this scheme is that it is to reduce the total carried traffic as much as smaller number of channels is allocated to a new channel. However, the God channels scheme present efficient spectrum utilization when dynamic channel allocation strategies are being used. Queuing of handoff calls is another way of to minimize the forced call termination due to unavailability of channels in the cell. There is actually a trade-off between the minimization in the possibility of forced call termination of handoff calls and the total carried traffic. Handoff call queuing is possible as there is a fixed time interval between the time and the received signal strength falls below the handoff threshold and the time the call is terminated due to the unavailability of the signal strength. The queue size in the delay time is calculated from the traffic pattern of the surface area, which has been already mentioned. It should be noted that the queuing of handoff calls does not promise a zero forced call terminations because large delays will force the received signal strength to fall below the minimum level required to maintain communication and therefore lead to forced handoff call termination. Coming to the interference and system capability. So interference means it is one of the major factors which is affecting the performance of the cellular radio system. So interference is interfering in the particular communicating data. Sources of interference consist of another mobile inside the same cell, an ongoing call in a neighboring cell, other base transitions, transmitting signals in the same frequency band, or any non-cellular system which accidentally transmits energy into the cellular frequency band. Interference on the voice signals could give rise to crosstalk, where the caller hears interference in the background due to the presence of unwanted transmissions. The presence of interference in the control channels gives rise to missed and the blocked calls. Interference is very dangerous in urban areas due to the presence of larger base stations and the mobile with greater or of noise. Interference has been accepted as the major obstruction in increasing the capacity of a system and is largely responsible for dropped calls in the network. The two major types of the interference that are taken considerations while allocating the channels to calls were co-channel and advanced adjacent channels interferences. While interfering signals are generated inside the cellular systems by cellular transmitters, but they are difficult to control. Their interference due to out of band users is very difficult to control, which happens without any word of warning because of frequency overload to subscriber equipment or intermittent intermodulation products. Then coming to the co-channel system capability. The co-channel reuse approach is very useful for increasing the efficiency of radio spectrum utilization, but it results in co-channel interference because of the same radio channel is being repeatedly used in the co-channel cells in a network. In this case, the quality of a received signal is very much affected both by the amount of radio coverage area and the co-channel interference. Co-channel interference takes place when two or more transmitters located within a wireless system or even a neighboring wireless system which are transmitting on the same radio channel. Co-channel interference happens when the same carrier frequency, that is base station, reaches the same receiver mobile from the two different transmitters. The first carrier mobile is C serving cell, and this type of the interference is generally generated because channel sets have been allocated to two different cells that are not far enough geographically and their signals are strong enough to cause interference to each other. Thus, co-channel interference can either modify the receiver or mask the particular signals. It may also merge with the particular signal to cause the severe distortion in the output signal. The co-channel interference can be evaluated by picking any particular channel and transmitting the data on that channel at all cost of the co-channel sites. And a cellular system, the hexagonal shaped things with the cells in the first tier of the figure, which is been shown below, is the test one, which is set up to calculate the co-channel. You just see the first tier and the interfacing cells, the mobiles and the serving cells. This is what the co-channel interference measurement at the mobile unit. The test mobile unit is not satisfactory but continuously moving it, serving in its cells. And where S by I is equal to signal to interference ratio at the desired mobile receiver, and S is equal to desired signal power, and I is equal to interference power. Excuse me. If you receive, for simplification, that decay is the same for the 6 interfering cells, that is D is equal to dk, then the formula of the above becomes S by I is equal to 1 by C, 1 by 6 into Q minus S by 1 by 6 power. And for these analog using frequency mobile modulation, the normal cellular practice is to specify S by I ratio, that is to be 18 dB or higher based on the subjective test. And S by I ratio of 18 dB is measured value for the accepted value voice quality for the present day to the cellular mobile communications, and that indicates the 7-cell reuse pattern of the S by ratio in the 18 dB. So these are all the performance of the interference limited of the cellular mobile systems, which can be calculated. The S by I ratio is greater than 18 dB, then the system is said to be the correctly designed. If the S by I is lesser than 18 dB and the signal to noise ratio is greater than 18 dB, then the system is said to be experiencing a co-channel interference problem. If S by I and S by N are less than 18 dB, S by I is approximately same as the S by N in a cell, and then system has the radio coverage of the problem. If S by I and S by N are less than 18 dB and S by I is lesser than S by N, the system has both co-channels interference and the radio coverage problem occurs. Therefore, the reciprocity theorem can be used to study the radio coverage problem, but it does not give the accurate results when used for the study of co-channel interference problem. Therefore, it is suggested to perform test 2 in order to measure co-channel interference cell side in the test 2. So this is about the handoff and all the technologies which has been placed.